guys, Mr. Gibson here. I'll show you guys how to make transformations from function notation. First, I'm going to show you guys what function notation is. And basically it's just a way of writing functions or output, kind of like a variable. But let me take it through. So it's this symbol right here, and we call it f of x. So what this means is the name of the function is f. It tells you that the input value is x, and the whole output will be this f of x, okay? Sometimes it's labeled as y. What I want you guys to think of is a function is something that takes in an input, runs it through the function, and gives you an output, okay? It's a little machine. What's nice about function notation, though, is across all types of functions, it can tell us a lot about transformations. So first, we've got left or right transformations. Now notice, if we have a number added or subtracted within the function, it's going to translate that function from its original place. So for example, if I have x plus k, it's going to translate the function k units to the left. If I have f of x minus k, it's going to translate it k units to the right. So I've got a little example here. I start with this function f of x. I have f of x minus 2. So all it did was took this whole function, this whole graph, and translated it to the right 2 places. That minus 2 means it's going to go to the right 2 places. Alright, so similarly we have up and down transformations. So notice that here we have f of x plus k, f of x minus k. The plus or minus k is outside of the function. If it's outside the function, it's going to translate it up or down. So f of x plus k means you're going to translate it k units up. Minus k, k units down. So here I've got g of x, so our function's g, inputs x. G of x minus 3, well, I'll take the function, split it down 3. So translated it down 3. G of x plus 3, split it up 3. 3 units up. Alright. Now finally, I'm going to show you guys when we have stretches or compressions. So if you have a number k multiplied by the function, okay, you're multiplying this k onto the function, it's going to stretch it or compress it. So it's not going to move it, it's not going to translate it, it's just going to make it skinnier or fatter. So if I have k is greater than 1, it's going to stretch toward the y-axis. So here's your example. You have f of x right here, and look, it stretches out this k times f of x out towards the y-axis. If k is greater than 0 or less than 1, it's going to compress, so it's going to kind of get a little fatter. So f of x right here, k times f of x, this k being between 0 and 1, and sure enough, it compressed it. It pressed it down, the f of x down a little bit to make it a little fatter. Okay? So let's look at an example real quick right here. I have 2 f of x plus 3 minus 4. I start out with this original f of x. So first it goes to the left 3. So I go over here to the left 3. And then it's going to be minus 4, so it's going to go down 4. Okay, so we're going to end up right there. Now the next thing is this 2 means it's going to stretch, so as you can tell it got a little skinnier. Okay, so that's how we went from, this told us the directions to go from this f of x to this new function to f of x plus 3 minus 4. Thanks for your attention.